Hello. Hello. Hi. Good morning, class. Can you all hear me? Okay. So I think let's just wait for 2-3 minutes and then we'll start. Okay. So hi, class. So let's just start with the section today now. Okay. So yesterday, what we were doing was we started with the hypothesis testing, right? So in the hypothesis testing, we were trying to understand like what exactly a hypothesis is and what are the different the we took some of the different examples in order to understand about the hypothesis, right? And we then try to understand like what exactly a null hypothesis is and what is an alternate hypothesis, right? That was the understanding that we created yesterday. We took some examples in order to understand that, and then we also understood how do we define a hypothesis, right? So we either say we fail to reject null hypothesis or we say rejection of null hypothesis, correct? So these are basically the statements that we use in order to tell which of the hypothesis was true or which we accepted. So these were the terms that we used yesterday over here. So this is the same thing, right? So this is a statement that we never use. Then we also try to understood about like basically how we start building our hypothesis, correct? So like the rule for that was like whenever you create a hypothesis, you should have a equal to sign, less than equal to, or greater than equal to sign in it. And the alternate hypothesis will always have a not equal to, greater than, or less than equal to sign. And we understood that by a Flipkart example over here. And yep, so this was the kind of stuff that we had done yesterday. So today, what we will be doing is just moving ahead with that, we will be starting with the concept of to understand how do we actually make a decision, right? So up till now, what we did was we studied that uh, what exactly a null hypothesis is and what exactly alternate hypothesis is. First thing is, how do we create it? Now, how do we justify or make a decision based on the hypothesis that we have, that whether we are, in a state to accept or reject? So this is something that we will be trying to understand today. So before I move ahead, anyone having any doubts, any specific thing that you would like to discuss before I move ahead?
Good morning, Amit. Raghu here.
Hi, good morning, Raghu.
Yeah, Amit. So last 1 hour I missed out due to power shutdown. Can we have just a quick recap? So what it is hypothesis, null hypothesis. So can we have our 5 minutes?
Sure, I'll just
If,
quickly tell you that.
sure, fine. Thank you. Thanks. Thanks.
So see, what we do is basically, what is hypothesis? Hypothesis is where what we do is, so just try to understand. So where did you left off? I mean, I would like to understand that. Uh, at,
I missed out that uniform and or norm, Amit. After that I missed out.
okay. So this was a fresh topic that we started off yesterday. That was hypothesis testing. So hypothesis testing is something, right? Like what happened is basically, what do we understand by the term hypothesis is that what is, so if I ask you like what is hypothesis, so English meaning will be something that is our assumption, right? What do we feel or what do we assume something to be as true? So for example, if I say that the average salary of an Indian is 10,000, so this is my assumption that I'm holding true for the entire population. Now my assumption is something that can be wrong also and it can be right also. So there are two outputs to this hypothesis testing. So what we do is basically in the hypothesis testing, we try to first of all create the assumptions, right? Where we write down that, okay, what basically our assumption is. Then we write a challenge of that. Basically, what is the alternate hypothesis for that? Okay, if this is not true, then what will be true in that case? So that is called as basically hypothesis. And in order to prove that, what we do is we use the hypothesis testing in order to kind of come up with the solution or tell that, okay, whether our assumption was correct or it was wrong. Now, in order to understand this, what we can do is, like, for example, let us take the example of the maximum amount of lead in any food product. Now, basically, as per the Food Authority of India, I mean the food, the compliances, the amount of lead in the food should not be more than 2.5 ppm, right? So this is like a general notion that is given by a FDI. So now, when something like this is given, so that means that that instruction is being followed by every company who is producing the food items. So now what will happen over there is, so it is my assumption that every company is following this this rule that is given by Food Authority. Now this is my hypothesis, right? This is my assumption that everyone is following it. Now what will be the opposite of that? The opposite of that will be that the company is not following that regulation, so they are having more than 2.5 ppm of lead in the food products, right? So this is something that we understand by the hypothesis and alternate of that. Same way, you have another example over here, like for example, in the court, when there is some, there is a criminal that is held for any of the crime. So what happen is there are two hypotheses that you have. So if you see, there is a lawyer, there is a judge, there is a lawyer. Now, the judge has a hypothesis that the defendant is innocent, that the person is not done any crime, but the lawyer is something who is fighting a case in order to prove that he is not innocent. So now what will happen is, if we are able to give the evidence that he has done the crime, so in that case this hypothesis will be true, and if we are not able to give that hypothesis, in that case the first hypothesis will be true. So this is something that we understand by that term, hypothesis testing. So what we do in this case is basically the hypothesis into two parts. The first part is called as null hypothesis and another is called as alternate hypothesis. So null hypothesis is basically a prevailing belief about the population. That means something that we already believe which is true. That is called as null hypothesis. And alternate hypothesis is something that opposes the null hypothesis. So if I say average salary of an Indian is 10,000, so that is my null hypothesis. What is an alternate hypothesis? Alternate hypothesis is something opposite of that, where I am saying the average salary of an Indian is not equal to 10,000. So it can be more than 10,000, it could be less than 10,000, but it is not 10,000. So that becomes my alternate hypothesis. So now what we try to do is our goal is always to prove this, right? Because now this is something that we already believe that this is true, but this is something that we are trying to prove that the belief that you have, that is wrong. So that is something that we do in this alternate hypothesis. Okay, so this is why we call it as, this is something that opposes the null hypothesis. Now what we do is, say for example, so I have an example that in the last year, so we calculated the time that the employees are taking to reach the office. So average time came out to be 35 minutes. Now this is my assumption that people take 36.5 minutes to reach office. So this is my null hypothesis, and alternate is that the people do not take 36.5 minutes. So it could be less or it could be more. Anything can happen in that case. So this becomes my alternate hypothesis. Okay, so now what happens over here is, when we try to actually prove the hypothesis, so when you are trying to prove, like for example, when we took the example of court case where we said that, okay, the person is innocent or the person is a criminal. Now what will happen is, one of these two cases will be coming as true, either this or this. So how do we actually tell, like, there's a statement that we use in order to tell whether, we accept the null hypothesis or we accept or we reject the null hypothesis. So there are ways, right? So if in case your alternate hypothesis is true, if this is true, you will say reject null hypothesis. So I reject null hypothesis. Okay, and if in case your alternate hypothesis comes out to be false and your this hypothesis is true, you will say I fail to reject null hypothesis. So if you say fail to reject means that you accept null hypothesis. So we never say I accept null hypothesis. The term that we use in statistics is, we say it as fail to reject null hypothesis. Okay, so any questions up till here? Anyone? I mean, if anyone would like to ask.
Thanks, MS. It's clear.
So, hello. So, sorry to
Yeah.
interrupt you. Actually, facts about that. Our planetary has eight planets. Okay, so our
Sorry?
planetary system has eight. Our planetary system has 8 planets, right? It's a hypothesis. Okay. If we include the Pluto in that, it's a 9. That's a alternate hypothesis.
See, so basically alternate hypothesis will be, so my assumption is that there are 8 planets. Okay.
Right.
So that becomes my hypothesis. This is my assumption, or this is my known fact that, our solar system has 8 planets in it. Now you challenge this and you say, there are not 8 planets. Now there are multiple statements that can be given by you, right? Just see. I am saying, just try to just see this. In the solar system, you said that my assumption was that there are 8 planets. Okay, I am saying there are 8 planets that we have in the solar system. Now, when you say, that we have 9 planets, so that becomes the alternate. No, so that cannot be my alternate hypothesis. My alternate hypothesis will be, either I will say we do not have 8 planets. So either we have more than 8 planets or we have less than 8 planets. Or I can also say we have more than 8 planets. So that is also one of my assumption, or the alternate hypothesis. There could be 3 type of cases that can be created. Or I can also say that I have less than 8 planets. So depending upon what you are trying to prove, you pick up the null and alternate hypothesis. Hello, yeah, Harmeet, is it clear to
Yes,
you?
sir, I got it. Yeah, I got it. I got it. Thank you.
And we will be understanding it more also, because this is something that we call as two-tailed or one-tailed test. So this is something that I will be explaining you further as well, like why we have taken this, why we have taken this, and what was this. So I'll be explaining you this further as well. Okay. So yeah, so basically, these were the things that we kind of we were discussing under the part of hypothesis testing. So we took a small example over here. So say suppose AC company. So the company says that they had average sales of AC per store per month as 350 units. So based on the historical data, so they knew that every month per store they used to sell 350 units. Now the weather has changed and the sales will not be equal to 350. Okay, so now what they are saying is that the weather has changed this time and the sales will not be equal to 350. Now, what is the general belief? The general belief that they had was that the sale is this. So 350 units, the average sale is 350. So this becomes my null hypothesis. And alternate hypothesis will be it is not equal to 350. Okay, so that becomes the null hypothesis in this case over here. So if you see my null hypothesis, so null hypothesis we denote by H naught. Okay, this is something that is defined by H naught. Alternative hypothesis is something that is either defined by H1 or HA. So you can write any of the two things over here. Yeah, just give me one moment here. Okay, sorry class. Yeah, so I was trying to tell you, like, what is null hypothesis? That is H naught, and alternate is something that we define by the HA. Okay, and then we saw that how do you formulate a null hypothesis? Null hypothesis is something that will always have a equal to sign, less than equal to, or greater than equal to. And alternate hypothesis is something that will have either a equal to sign or greater than or less than. Okay, so this is something to always remember, that what will be your null hypothesis and what will be your alternate hypothesis. Now, in order to understand in that case, what we did was we understood a small example yesterday, right, where we took the example of Flipkart. So Flipkart claimed that its total valuation in December was at least $14 billion, and now they, the here the claim is more than, right? So what is my null hypothesis? That the total valuation is more than equal to 14 billion. What will be my alternate hypothesis? That it is less than 14 billion. Similarly, in the second situation, what happened was Flipkart claimed that its total valuation in December was greater than 14. So greater than 14, what does this mean? Greater than 14 means means over here that the total valuation was more than. Now it doesn't have a equal to sign in it, right? So that means it becomes my alternate, and null will be less than equal to the 14 billion. Just give me one moment. Let me plug in the battery. Okay. So class, so are we all clear on this? Like how these two hypotheses are created? So null hypothesis is something that will always have a equal to sign in, right? So in this case, although my claim was greater than, but still my null hypothesis became a opposite of that, correct? That is less than equal to, because in that greater than, I do not have a equal to sign coming up. So I had to take that as my alternate hypothesis. Okay. So these were some questions that we did yesterday, right? So now, today what we will be doing is, before I go ahead, right? So please let me know if specifically we have any other doubts on this. Because like yesterday we did this in a lot of detail as well. I mean the questions, the examples that we did. So it was just a quick recap for all the things that we did yesterday. If still you want me to, do something again, you can let me know.
Yeah. So Amit, I mean, the only confusion that I have is like, when we are creating these statements, right? So when from reading a statement, like we had these two uh, examples of the flip card. So
Mhm.
the only challenge is how do we create these statements, right? Saying, okay, now this would be your null hypothesis, which says greater than equals to, and then the alternate would be your, the alternate hypothesis.
See,
Because
basically the
in the first one we took something like equals to some sales. In the second one we are taking the alternate hypothesis.
right. So you were there in the yesterday session.
Yeah, I think for the last 15 minutes I was not there.
Right. See, so I'll just tell you, I'll just repeat that part. So basically, see, the key rule to understand like what will be your null hypothesis is, just remember that null hypothesis will always have a equal to sign in it. Okay. So now when I say equal to, now equal to sign is something that comes in three ways. One is normal equal to, this is equal to sign. I say greater than equal to. This also has a equal to sign. I say less than equal to. Now this also has a equal to sign, correct? So now if you will see, if we are having any of these three signs in my hypothesis, that will be my null hypothesis. And opposite of this, see null alternate see there are two hypotheses that we have. One I can say is direct hypothesis, another one is the alternate of that, right? So
Hmm.
opposite of not equal to what, opposite of equal to, what will be that? What will be the opposite of equal to?
Not equals to.
Not equal to. Okay. What will be the opposite of greater than equal to?
Less than.
Yes. So this becomes the less than, and in this case it becomes the greater than,
Greater than.
right? So now if we read this statement, Flipkart claimed that its total valuation in December was greater than 14 billion. Now, what is the statement? The statement says greater than 14 billion. Okay.
Hmm.
Now, because it doesn't have a equal to sign, right? It doesn't have a equal to sign. So what will it become? It will become alternate, right? It will be call it. I will be calling it as HA. That is alternate hypothesis. So what will be my null hypothesis? Null hypothesis is something that is the opposite of this.
Less than equals to.
Less than equal to 14 billion. So my null hypothesis becomes less than equal to 14 billion. Okay, so now if you see, this is the same thing that we are getting. So alternate hypothesis is this greater than, and null hypothesis is less than equal to. Okay,
Okay.
now
Yeah.
if I, yeah, so now if I go back to my previous example over here, the we did basically two of them. Now, if you see what was the claim in this example, if you say Flipkart claimed that its total valuation in December was at least 14 billion. Now, at least means, more than or equal to 14,
Right.
right? So it is, they said that it is more than equal to 14. Now, this has equal to sign in it. So what will this become? This will become my null hypothesis. And what will be my alternate hypothesis? Opposite of this, that is less than 14 billion. So that is what I get. So this, because it has a equal to sign, this becomes my null hypothesis. And this doesn't have a not equal to sign, this becomes my alternate hypothesis.
Okay.
Clear?
Yep.
So now what we'll do is we'll move ahead with this. Now, similarly, we had these questions over here which we were trying to take. So we will just come back to these things in a little bit of, these are like still we have done it. But now, we will be doing the important part. How do we make a decision, or how do we come to a point where we can say that whether my null hypothesis, I reject null hypothesis, or I fail to reject null hypothesis? How will I come to that point? So this is something that we will be learning over here. Okay. So in order to understand this, we have a small example. Okay. So Apurva claims, right? Apurva is a lady. She is a player of archery, and she claims that she has an average score of 70. Okay. Now, please, if just understand this example. With this example, again, your concepts will become clear on the hypothesis testing. Now, I'm saying the average score in archery. She claims that her average score in archery was 70. Now, if she is giving this statement, okay, first of all, if she is giving this statement, how she would have come to this point? How would she have come to this point? Can anyone tell me? Like, so suppose if I say Sachin, right? Maybe I can take a better example of that. Sachin say, if Sachin has, say, suppose he has an average score of 55. Sachin has an average score of 55 scores in the one day ODI matches, right? So what do I mean by this, that he has a 55 as the average score? No, that is just the formula, right? Total runs by total matches. So that is just a formula that we have. But as a layman's understanding, what will you understand by this? If I say, he has a score, he has a average score 55. So what? See, this is not this question that I'm asking is nowhere related or anything. It is general statement that I'm saying. Okay, very general statement. So in a very layman's stuff, so if I say that that his average score is 55, nobody does not say that it is.
Sir, that means, there is a lot of chance that he would score his score would be more than 55, or approximately a little bit less than 55.
So it can be anything, right? So it is like an average that I'm saying. Okay, now when we talk of average, so it is simply I'm saying that if whatever matches he has placed, so there would have been scenarios where he would have been out on 0 also. There would have been scenarios where he would have created 200 also, right? So I cannot say it was always near to it, but yes, most of the times what he was scoring it was nearby to the 55. Now again, if I again go by the simplistic language, so if I say that there is like right now the IPL is going. Now there is a new player that has come up into the IPL, and he has placed 4 matches. And in the 4 matches, whatever his score was, I said he has a average score of 25. And I have a score of Sachin with me, who has an average score of 55. According to you, which number you will trust more? Will you trust this number more, or you will trust this number more? Okay, so Sachin, right? So output will be Sachin over here. Why so? So Yash or Raghav, why do we say Sachin over here?
I think it's because of the sample size that we have.
So don't go by sample size. See, I'm talking just in layman's language. So don't just, we will not talk of the basically the any of the statistical term over here right now, because if we understand that part, something that is where this hypothesis thing is going into that direction. See, a person who is not familiar with the statistics, he will say, yeah, Sachin has played a lot of matches, man. He has played a lot of matches. He has played 300 matches. So when after 300 matches, I am saying that his average score is 55, and there is another guy who has just played 3 or 4 matches, and then you are telling me his average score is 25. How shall I believe this, man? Right? This 55 is something that I'm getting after he has played 300 plus matches, and which are of different demographics. He would have played into different countries, different grounds, different temperatures, different weathers. That is when he came out with this score. Am I right in saying that? See, I have not used any statistical term over here. I'm just trying to give the very simplistic explanation, which you will give to your friend as well. That, you know, he has played so many matches, man, and under different pressure, different techniques, different games. Then I'm saying, you know, that this guy has an average of 55, and this guy just had 4 matches with him, where I do not know that, you know, like what the conditions were, and at which place did he come in the first match, at which place did he come in the second match. I am not aware of anything, so I am not pretty much sure on this number 25. Okay, so if you see over here, what was the population? What was the population over here? So population was the all the matches that Sachin has played. That becomes my population. The population will be that. Population is what? The complete data, right? The overall data. That is something that we call it as a population. When I say I want to, like, you know, basically, like the very first example that we started with off with was like, I wanted to say that I want to calculate the average salary of India. So the entire population of India, we were taking it as a population. So population is a term basically where we take entire data. Okay, so we had 300 plus matches with us, which is the population, on the basis of which I am saying he has an average of 55, and he claims. So Sachin said that, you know, I have a average of 55. So same fashion, in a very same fashion, we have an average score of 70 for Apurva. So we are assuming that Apurva has played lots of matches, and on for all the matches she has played, she is claiming that her average score in archery is 70. Correct? Is it making sense to you? Right, guys? Okay. Now what I come over here is, now if you remember, yesterday we discussed something. What we do is, in the hypothesis testing, we already have a belief about the population, and from the population what we do is we take a sample, and on that, by taking that sample, what we try to do is we try to prove whether that assumption that we have, is it true or is it false, right? That is what we do. So this is what we do in the hypothesis testing, because we already have a general belief. Like, you know, in the case of that court case, I said that, you know, the judge always sees everyone with an eye that he's an innocent. The judge already has a notion about that culprit that he is innocent. Okay, till the time you give me a evidence against him, only then I will be able to prove him that he is a culprit. Now same is the case that I am doing over here. Now what I do is, now she plays 5 games. Okay, she plays 5 games. Now in the 5 games that she played, in those 5 games, her average score came out to be 20. Okay, in the 5 games that she played, so you took a sample of 5 games, you said, okay, let me see how she plays in the next 5 games, and whatever the average will be, I will try to prove whether my null hypothesis is true or it is false, right? So what is my null hypothesis over here? All of you please tell me, what is the null hypothesis over here? So what is the null hypothesis? Correct, right? So Pooja, Sakshi, Yash. So my null hypothesis over here is that that the average score is equal to 70. Okay. Now what is my alternate hypothesis? What is my alternate hypothesis? Right. So alternate hypothesis is that it is not equal to 70. Now these are the two hypotheses that I have. Okay. Now what I will do over here is, this is my HA. Okay. Now what happens over here is, see now again, this is something that is very generic that I'm talking, not in a lot of statistical terminologies. Now you saw her 5 games and her average score in the 5 games came out to be 20. Okay, she played 5 games and her average score came out to be 20. Will you still believe her that her average score has been 70? Right? She plays 5 games in front of you and her average score comes out to be 20. Will you still believe her claim that she is her average score would have been 70? No. Okay. Now what you do is you watch another 5 games. In those 5 games, she scores 65. Okay. She scores, her average scores come out to be 65. Will you believe her claim that her average score would have been 70? Believe that claim? Right. Yes, you will believe that because now that 65 is very near to 70. Okay. So now just think in your mind. Just think in your mind. So when she says her score in archery is 70, okay. So in your mind, you set it up a small figure. You just set it up a small figure that, okay, if she scores around 65 or 64, I will believe her. Even if she scores 74 or 75, I will believe her. Right? See, when I'm saying average score in archery, so her claim is 70. And now my alternate is it can be more than 70 also, it can be less than 70 also. Right? If I prove that if her score was more than 70, then I will say Apurva, you are underestimating yourself. Your average score is not 70 but it is 80. And if suppose I prove that her score is 60, I will say Apurva, you have been overestimating yourself, that your average score is 70. No, it is not 70, it is 60. Am I right in saying this? This is how you will talk to her, right? If she is doing good, you will say no, lady, you were underestimating yourself, your score was 80. Right? If she scores less than that, you will say, lady, you are overestimating yourself, your score is not 70 but it is 60. Okay, but in my mind there are some figures that I am taking. I am saying that, okay, if she scores around 64, 63, I will assume, okay, she is right in her understanding. But if the score comes below 63, I will tell her that, Apurva, you are overestimating yourself. Your average score is not 70, it is less than 70. Will I say that? Right? Now, same way, there is a figure into my mind on the upper side as well. If I say that, if she scores around 73, 74, okay, it is very nearby to the average. I will tell her, okay, Apurva, you are right in your claim. But if her score comes out to be 77, 78, then I will tell her that, no, Apurva, your average score is actually more than 70. Okay. Now, based upon this, I will be proving my null hypothesis, whether I reject it or I fail to reject it. So how do we decide that value, right? That value around that 70, what that value should be? Should it be 64, 65, right? Or it should be 75, 77. So how should we come up with these numbers? Now, this is something that is called as making a decision. Okay, so if output lies between 75 to 64, I will say that she is correct in her claim. If it lies outside that range, I will say she is wrong in her claim. Are you able to make the sense now? Plus, anyone who is not clear on this? Anyone, any doubt up to this point? Okay. So now what I'll be doing is, let us move ahead. So you have a question over here. What would be the null hypothesis and alternate? So we have already created this also, but still you can just try it out at your end. Please read the statements also, the feedback, why that answer is coming up. So you have all the things over here. Okay. So the null hypothesis is equal to 70, alternate is not equal to 70. So now we will understand this with the help of a graph. Say based on all the games she played, her average was 70. Okay, so what distribution is this? This is a normal distribution, right? In the number of matches she scored less also, in a lot of matches she scored higher also. Now this is what we are assuming, that this is what she is claiming, that her score was 70. Now let me assume, right? Let us assume that the average of 5 games, it comes out to be 50. Okay, the average of 5 games that she plays, the sample size that we have taken, that comes out to be as 50. Now the point is whether this 50 should be accepted, as that, her claim is true, or on the basis of 50 should I reject that, what she is saying is false. Getting it, class? What I'm saying over here? The same thing I'm just repeating over here with the number 50 over here. So she scored 50. Now I have to tell whether based upon this number 50, should I accept her claim or should I reject her claim? So which over here, which value can be referred to as the population mean in Apurva's archery example? What value can be referred as population mean? What value will be that? 70, right? Because that is something that is already given, that for all the games what she has played, what was the mean value? That was 70. Okay. Now this comes the area which I was trying to tell you, all of you. If you see in this chart, what we have done over here is we have defined something over here. This is LCV, this is UCV. UCV stands for upper critical value, LCV stands for lower critical value. Okay, so now we are saying that if the value lies in the red area, over here, this means this is a rejection zone. This is a rejection zone. That means I will reject null hypothesis. But if the value lies in this white area, this is called as acceptance zone. Acceptance means that I fail to reject null hypothesis. Correct? Right? This is the same thing, right? It is just that I am representing it with the help of a chart. That if it comes up till 75, I am saying, okay, she is true. If it comes more than 75, I am saying, no, her average is more than 70. Same way, if up till 50, 40, the value comes up, I am saying that she is true in her claim. If the value comes further down, I am saying she is, false in her claim, that her value should be, her average should be, her average is less than 70. Okay, this is just the same thing that I've represented in the form of a chart over here. Okay, or are you all clear on this? Anyone having any confusion or doubt onto this?
Amit, Yash here.
Yeah, Yash.
I have a doubt. Like, if we assign this lower critical value and upper critical value, there would be also a case where the score is 0 and in the next match is scoring somewhat like 110, 120, like you said. So in this case, both limit would be crossed, right?
Sorry, I couldn't get it.
Like the average would be 70, even if it crosses lower critical value or upper critical value. Hello.
Yeah. So no, I mean, see, let's break this again. You said that there is some number 0 and there is some number 100.
Yeah, I'm saying that the average would also be possible if it crosses the lower critical value or upper critical value.
So it will be one of them, right? It will either cross LCV or it will cross UCV.
Yes.
So if it crosses LCV, this is the critical point. So what is the critical point? So critical point basically is something where we are saying that if this value is less than 45, if the value is less than 45, so whatever it is, if it is less than 45, 40, 30, 31, 0, whatever it is lying into my critical region, right? in that case, what I'm saying is I reject my null hypothesis, or because the value is too small. If the average comes out to be very high, so it is, say, suppose my critical value was that if I'm saying that if the value comes more than 80, now more than 80 could be anything. It could be 90, 100, 110, 120, anything, right? So that is basically something that is called as your upper critical value. So if the value comes more than this, it will be basically told as that, again, we reject the null hypothesis in this case. So it will never be a case where both the values will be coming. Making sense?
Yeah, got it.
Yeah. So Rishabh, X bar is it's not the next match average, it is the average of all the 5 matches that she has played. The average archery score for 5 games. This is what that 50 is. So this was the average score that she had in the 50 matches. Okay. So now these area are called as critical region, and the middle area is called as acceptance region. Okay. So just try to see. This is an example. If suppose this 50 value lies inside the critical region, what do I say? I say I reject the null hypothesis. Okay, so we are just assuming that 50 lies in the critical region. So in that case, what I will do is I will say we reject null hypothesis. And if that 50 lies in the acceptance region, it was not in the critical region, I will say we fail to reject the null hypothesis. Right? Is it clear? Now this is important to understand. These 2 slides, what we are doing over here. Okay. Now what we'll do is we just move ahead with this. So if your sample mean lies in the acceptance region, then what does it mean? If your sample mean lies in the acceptance regions, right? So you fail to reject null hypothesis, right? So you will fail to reject the null hypothesis. This is what we understand by this term. Okay. So now we will learn more about these critical regions that we have. Okay, now these critical regions are of 2 types. Okay, these critical regions that we have, they are of 2 types. One is called as directional and another is called as non-directional. Okay, class? So the hypothesis can be of 2 types. One is directional and another is non-directional. So what do we understand by, first of all, what we'll do is we will take an example of non-directional. Okay, we will try to first see what is a non-directional. If you just take a look at this, so this is just purely based upon the examples that you will have. See, when I said that my average score is 70, okay, this is my null hypothesis. Now, on the basis of null hypothesis, my alternate hypothesis comes out to be my average score is not 70. Now, when I'm saying my average score is not 70, what are the possible outcomes that I can have? What are the possible outcomes that I will have? Please tell me. If I'm saying my average score is 70 and my yes, right? So all of you are saying it right. It is less than or more than 70. So Rishabh, please be careful with your these things. Most of the time your answers are coming as wrong. So it will not be more than equal to or less than equal to. It will be more than or less than. Right? So if you see over here in this, the alternate hypothesis will be true in case it comes less than or more than 70, right? Now, in this case, what is happening is in this scenario, your critical region is lying on two sides, over here also and over here also. Am I right in saying this? Because if the value comes too high, I will reject null hypothesis. If the value comes too low, again I will reject the null hypothesis. Am I right? So my critical region is on both the sides. So this is why we call it as a non-directional. Non-directional means I am having critical regions on both the sides. I have a critical region over here also and over here also. Now what will happen over here is there is another type of a test that is called as directional hypothesis. Now directional hypothesis is, now her claim was, Apurva's claim was that my score is greater than equal to 70. Okay. Now her claim was that my score is greater than equal to 70. So what will be my alternate hypothesis in this case? What will be my alternate hypothesis? Less than 70, right? So the alternate hypothesis will be less than 70. Now in this case, if suppose my output comes out to be very high, if output comes out to be very high, will I reject null hypothesis? If my output comes out to be very high, will I reject my null hypothesis? No. Right, Sahil? So your answer is correct. No, we will not reject it because she is claiming herself that her average score is more than 70, more than equal to 70. So if it comes out 90, 100, 130, 140, whatever it is, till the time it is more than 70, I am saying I fail to reject null hypothesis, right? I will only be able to reject null hypothesis if the value comes low. If the value comes low. So I do not have my critical region on this right hand side. Okay, I do not have any critical region on the right hand side. So this is something that is called as directional hypothesis. Okay, this is something that is called as directional hypothesis. And the type of test that we do over here, they are called as one-tailed test. One-tailed test, why? Because I am just having the tail on the one side. And in the previous case, we had the tail on both the sides. So this is called as two-tail test. So I have one tail over here, one tail over here. So we call it as a two-tail test. And since in this case, I just have the tail on one side, I will call it as one-tail test. Correct? Is it right? Now, let us just change the question over here. I say her claim is that she will score, that her average score is less than equal to 70. How will this curve look like to me? How will this curve look like to me? All of you create at your end. Her claim is that her average score is less than equal to 70. Okay, and my alternate is that it is more than 70. Okay, this is my alternate hypothesis. So now how will the chart look like? All of you please create at your end. Yeah, so Sahil, we do not call it as a high, so it is upper, lower and upper. Okay, upper tail test.
So Amit, I have a question. So only when we have the case of equals to, that's the time probably like we will have this the two tail test, like in both the ends. When we have this less than equals to or greater than equals to, then the scenario would be mainly around the one tail test. Now the red portion that we are seeing here, right, they will also have a specific value. How are we defining those values?
Yeah, we will be coming to that point. We will be coming to that point.
Okay.
Right now we're just understanding the test.
Okay.
Okay, so is this clear to all? Like what is upper tail test, what is lower tail test, and how do we define these three things? Right, so simple and to understand. If it is more than equal to, it is upper more than equal to or less than equal to, it is one tail, and if it is equal to, it will be a two tail. Okay. Now, since we have understood this, now just a quick summary of all the things. Just take a look at it. Just read it once. So is it clear to all?
Ahmed Sahil here.
Yes, I.
Hello. Yeah. Just to clear on how we define a directional or non-directional test, it basically means in a directional test it will either be a lower tail or upper tailed test, and in non-directional it will be we'll have critical regions on both the sides, right?
Right, right.
Okay. Thanks.
Now what I'll do over here, so let's try to understand. So we have a quick question over here. Okay, so government regulatory have specified that the maximum permissible amount of lead in any food product is 2.5 ppm, or it should be, it is the maximum or this. If you conduct test on randomly chosen mangi samples from the market to see if its lead content is above the permissible, what type of test would be this? You have to tell me what type of a test will this be. Okay. Yes. Just give me a moment, class. Actually, I'm just opening it. Just this output over here. You will not see the output, right? So that is why I'm doing this. So actually, I have these answers also into it. So yeah. So we will see it over here. So what type of a test will it be? Right. So Prerna, Neshwari, so all of you are giving the right answers over here. Okay, so it will be an upper tail test, right? So others, you also just think of it. Just take a look at the question. Try to make a small chart at your end. Try to visualize it, right? And come up with the answer. Just don't see and hit a guess that it is lower or it is upper. Understand it, create it, and see it. Raghu, so are you able to understand this? Like what this output will be?
Yeah, Ahmed. Yeah.
Okay. So if I just do it. So Raghav, you also give the correct answer although. So it is what is the condition that maximum is this? Okay, the maximum is this. So what will be my null hypothesis in this? That it is less than equal to, right? Lead should be less than equal to this, and alternate will be more than. Okay, alternate is more than. So if this is a curve that I have created, okay, so we are saying it should be less than or equal to 2.5. When will I be what test I will conduct? It will be upper tail test, because if it comes out to be higher than this, it falls in this region, I will reject my null hypothesis. Correct? This is what I will be doing. On this side, if the value comes to be very high, and that is on this right hand side, if the value lies in this, that means I reject my null hypothesis. So this will be a upper tail test. So if I just see, so yeah, so most all of you have given, so Raghu, Akshay, so all of you have given me the correct answer. Anyone still confused on this? Rishabh, again, your answer is wrong. So please, I think what you are doing is you are just trying to give the answer quickly. So take your time, think on that, and just then give the answer. Yeah, definitely. So that is why I'm saying, so right now we don't have to go by time, right? So right, Raghav, so you have to take the time, understand the question, and then come with the answer. So definitely, so your concern is totally valid. So I'll be stuck on this. I'll just wait for all of you to give me a go ahead. If any one of you still has any doubts, you can let me know. Okay, shall I move ahead? Okay, so we have the another question over here with us. Oh, so okay. So Subhagran, you realized that the answer is not correct. Okay. So Bhuvaneshwari, you saying it is no. So Bhuvaneshwari, just try and take a look at it one more time. Will it be a upper or will it be a lower? Right. So it will be lower test. Right. It will be a lower tail test. See how I think there is a little confusion that you all have. So test is decided upon what? Who will tell me? On what basis are we deciding our test? Are we deciding the test on the basis of null hypothesis or is it on the basis of alternate hypothesis? It is alternate hypothesis if you will try to see, right? If you will actually see what is the general notion over here, it is basically we are saying that the upgrade employee takes 35, at least 35 minutes, at least. Okay, that means if I say at least 35 minutes, that means greater than equal to 35. Is it correct? That this is the minimum time that they take? Okay, so this is my null hypothesis. What is my alternate hypothesis? It will be less than 35. So more than null is on this side. So on which is the alternate? Alternate is on this side. So if value comes out to be too small, then only I will be able to reject the null hypothesis. So it is a lower tail test. Correct. Right, Vishal? So you are saying correct. The understanding that you have is that is totally correct. So on the basis of alternate hypothesis, whichever side the alternate is lying, that is my test. So when you said average score is equal to 70, okay, and then your alternate was your score is not equal to 70. So because your test was that it is not equal to 70, that is why you created two critical regions, right? It could be more also, it could be less also. That is why you created two critical regions. It was because of the alternate hypothesis that you created the hypothesis over here, the test over here. Correct? Is it correct to all of you?
I have a counterpoint, Amit. If it's after when we read and understand the null hypothesis, we come to a conclusion of what exactly has to be proved, right? So, doesn't that mean that the type of test that we decide to have is based on the null hypothesis?
No. See, what you are doing over here is what is your test that is doing over here? So if you actually see, so alternate is just an opposite of that, right? So null
Yeah.
hypothesis and alternate, the only difference between them is that they are just opposite. So what I am saying is wherever at whatever side my alternate hypothesis is true, that is the side where my critical region is lying, right?
Yeah. Yeah.
So that is why we are saying that it is dependent upon the alternate hypothesis. So in this case,
Okay.
my
Okay.
alternate hypothesis was lying on the left hand side, so I said lower tail test. In the previous question, it was lying on the right hand side, so I said upper tail test. When it is lying on both the sides, so I'm saying it is two tail test. Okay.
All right. All right. Understood. Understood.
Okay. So we have this over here. One more question. So all of you, please try this. Oops. So you have to create the null and alternate hypothesis. A researcher claims that the weight of an average Bengal tiger is less than 220 kg. All of you, please give me the null and the alternate hypothesis on this. So everyone has given a wrong answer. Right. So Rishabh, this time your answer is correct. So that is the main thing, right? So you took your time, you gave the answer. So Pooja, wait. Right. So Pooja, your answer is also correct. Bhuvneshwari, your answer is wrong. Sakshi, yours is correct. Yash, your answer is wrong. Nandini, your answer is wrong. Okay. So just see the question. What is the statement? What is the statement? So Ashutosh, we are not talking of the upper tail or lower tail. Over here, we are just talking about what your null hypothesis will be and what will be your alternate hypothesis. This is what question is. So first of all, you need to frame what your null hypothesis will be. So my null hypothesis will be, so if you see the statement, what is the statement? The researcher says that the weight of an average male is less than 220 kg. What is the condition that I have? What condition do I have? Okay. If you just take a look at it, what is the condition? My condition says less than 220, right? This is what the condition given to me. The researcher is saying that the weight of an average male tiger is less than 220 kg. This is what the statement is. Have I written it correctly? All of you, please validate this. Or have I written it wrong? Is this correct? Okay. So what is the criteria for a null hypothesis? What is the criteria for a null hypothesis? Equal to sign, right? Correct, Rishabh, right? So in the null hypothesis, we should have a equal to sign. Do I have a equal to sign in this? Do I have a equal to sign in this? No. So can this be a null hypothesis? Can this be a null hypothesis? No. What will be this? What will be this? Alternate. So this becomes my alternate. If this is my alternate, what will be my null hypothesis? What will be my null hypothesis? Greater than equal to, right? So it is greater than equal to 220. So my null hypothesis is that the weight is greater than equal to 220, and my null hypothesis is that the weight is less than 220. Clear to all? What type of a test will I do in this? What type of a test will I do in this? So Rishabh, again, are not upper, it will be lower, right? It will be a lower tail test. Why lower tail test? Because this is what my condition is. I am saying alternate hypothesis to be true as less than. So less than is always on this side. So it will be a lower tail test, right? Had it been the opposite case that I had to prove that the weight will be more than 220, then it would have been a right tail test. Okay, so I think it is making sense to all of you now. Perfect. Okay, so let us move ahead over here. So now what I'll be doing into this is just clear out these drawings. Oh yes, Rishabh. So upper and lower, it depends upon that less than and greater than to sign. Less than means lower, greater than means upper. Okay. So now, so these are the things that we have understood that, hypothesis testing is of two type, null and alternate. There are two type of tests that we have, two-tailed and one-tailed. And now how do we make a decision? In order to make a decision, we have a technique that is called as critical value method. Okay, we have a technique that is called as critical value method. So all of you are already aware with these things. When you will see the slide, you will be all able to understand it. Critical value. So like, the UCV and LCV that you saw in the previous slides, upper critical value, lower critical value. So now how do you get that value? So this is something that we will be seeing now over here. Okay, so let us take an example. Say suppose the population mean is 350. Okay, I just have, say suppose, let us take that the same AC example. Do you remember that AC example? Car AC example, do you all remember the AC example? Do you all remember it? That so there is a AC store in which they said that they had average sales per month per store of 350 ACs. Okay, this was that data. So that was the population. This is the population mean. Okay, this is the population mean, and this was the this is the standard deviation that is given to us. This is the standard deviation of population. Okay, this is the standard deviation of population. Correct? Are we all clear on these two numbers? Nothing new in this. Are we all sorted on this? Okay. Now what will be my null hypothesis? My null hypothesis is that the mean is 350, right? What is the alternate hypothesis? What is the alternate hypothesis? Not equal to 350. Correct. Now, in order to prove my alternate hypothesis, what I did was I took a sample of 36 stores. Okay, I took a sample of 36 stores. In order to validate whether I am correct in my understanding, our assumption is correct or it is wrong, we took a sample of 36 stores. Okay. Now, all of you please tell me, I have taken a sample of 36 stores. What will be the standard deviation of this sample? What will be the standard deviation of the sample data? Is question clear to all? I want you to give me the sample deviation or standard deviation of this sample. 27. How have you got this point of 27, Rishabh? So there is only one correct answer that we have got, that is by Pooja. So do you remember yesterday we did something that is called as CLT, Central Limit Theorem? So we spent a lot of time onto that. We did some coding also. We calculated the standard deviation also. We took a sample of 4, we took a sample of 9, we took a sample of 16, right? We had a standard deviation of the entire population. So how did we calculate the sample population for a sample of 4, of a sample 9, of a sample 16? Do you all remember this? What was the formula for calculating the standard deviation? It was 90 divided by square root of 36, that is 6, which will give you 15. Okay, so this is how you will calculate the sample, the standard deviation of the sample. So I know what was the standard deviation of the population. I know what was my sample size. So I can calculate my standard deviation because I know the formula for that, and which was proven also, which was proved by the central limit theorem as well. Am I right? Okay. Now, so the same thing. This is my null hypothesis. This is my alternate hypothesis. Okay. So now what is happening is, if my mean comes very far from 50, I will reject null hypothesis and accept alternate hypothesis. If my sample means comes very close to 350, I will say H naught cannot be rejected. Right? These will be my two consequences. These will be my two consequences. See, I'm trying to explain you hypothesis testing in as much detail as I can, right? It's just like every statement, it's there on your screen over here, and you can make sense out of it, right? So you have H naught, this is H1. H naught, because how will you prove whether your H naught has to be accepted or rejected? If the sample means comes out to be very far from 350, you will say you reject. If it comes very close to 350, you will say you cannot reject. Am I right in saying this? Please just spend a minute and read the things. All these things are self-explanatory. Okay. Anyone, any doubts on this? Shall I move ahead? Okay. So now let's do this question over here again. So this is what you have to find. Please try this question. Okay. So Subhakran, you say 50, Prerna 15, Baldev 15. Anyone else who is getting a different answer? Perfect. Right. So it is the same question, right? It is the same question. It is just that the wordings have been little complicated. That's it. Nothing is changed in this. So the answer will be the same 15. Right? If you just try to see over here, do not get misleaded by the big statements that are written. It is saying what will be the standard deviation of the sample. If the population mean is this is the population mean. This is the population standard deviation. Now they have given you a sample mean and they're asking you what will be the standard deviation of this, right? So sample size was 36. So 90 divided by 6, that gives you 15. That is what your answer will be, right? So these terms that you see over here, this term is just to make you a little confused over here. But till if you understand the concept, I mean, you just have to figure on that numbers over here, what you actually need to get that output over there. Okay. Now over here, what we'll do over here is, so this is something that you can see that how we have found that the sigma standard deviation for the sample that comes out to be 15. Okay. So now we are trying to calculate the things. Now over here, what we do is, there is something that we call it as alpha. Okay. Now, if you see, there is something that we have defined over here as alpha in this slide. This alpha. Now, this is called as alpha 0.005. Okay, this is something that what we have done is, this is something as a standard that is taken up. Okay, as a standard that I'm saying is that the error, okay, this is the percentage of error that we assume that we can have in the claim that we are stating. Okay, so if I am saying that I am having, if I am saying that that I reach my office in 37 minutes, this is my null hypothesis, right? This is my null hypothesis. Are you all correct? Are you all understanding it right? Now, if I say it with 100% confidence, if I'm saying this thing with 100% confidence, do I need to do an alternate hypothesis on this? If I'm saying it with 100% confidence that my sample, my average time is this, so there is no need of doing an alternate hypothesis, right? Because I'm saying something with 100% guarantee, right? When you buy something, when you buy a product, and on that product it is written that if the product gets damaged, or I mean if the product stops working, they will do 100% replacement. What do you mean by 100% replacement? That complete product will be changed. They will not come and change the part. They will do 100% replacement of the product. This is what you understand by the term 100%, right? But whenever we give any of these terminologies, we always say it, we always consider it that these null hypotheses are given with 95% confidence interval. Okay, now this is a market standard that we assume, that we are saying with the 95% confidence that I will reach my office in 35 minutes. Remember, we studied something that is the empirical formulas, 68%, 95%, 99%, right? Those were the empirical formulas that we studied. Now, this is something somewhere related to that only. Okay. So now I'm saying I will reach to my office in with 95% confidence. I am saying that I will reach my office in 35 minutes. So what is the probability of error in that? What are the percentage of error in that case? 5%, right? If I'm saying something with 95%, so there are chances of 5% error in it. So that 5%, that error is called as alpha. Is this clear to all? Okay. Right. So I get a lot of yeses over here. So in what scenario? Now, in what scenario will my alternate hypothesis be true? In which scenario my alternate hypothesis will be true? Right, that is the 5% region, correct? Right, so if I am saying if my data point lies in that 5% region, if in that error rate, right, so that in that case I will be saying that my alternate hypothesis is true. Now the entire area is called as 100%, right? We understood this, that under this the curve, under this curve we have the overall area that comes under 100%, right? This is the entire area of curve which is 100%. Do we all agree to this, that the area that we have under this curve, that is completely 100%? Now say suppose it is a two-tailed test. If I am doing a two-tailed test, what will happen in that case is this 5% error will be divided into two parts, 2.5 and 2.5, because overall is 100, and in the two-tailed test we have the critical regions on two sides, one on this side, one on this side. So my alpha will become, my alpha is 5, so it will be split up into two parts, right? 2.5 here, 2.5 here. I will get 2.5 over here and 2.5 over here, which, if I change it into a decimal, it will be 0.025. Okay, now please understand this alpha is a market standard, okay, that we assume it as 5%, and in many of the companies this is also considered as 3%, 2% and 1% also. Okay, but all the examples and everything that we will be doing in the entire curriculum is, everywhere we will be assuming that percent of error is 5%, because in 90% of the projects wherever you will be working, over there alpha will be treated as 5% only, right? This is like a standard value that is taken, but please do not consider this as the final value, that the value cannot be other than 5%. It can be 3% also, it can be 10% also. Sometimes when your data is very much, the data is, you do not have good data with you, so there are high percentage of error that that are bound to happen. So in that case you take alpha as higher as well. Okay, is it making sense to all of you? Anyone still any doubts onto this? Okay, now I know that 2.5 and 2.5. Now what I'll do is, let me just move ahead. So just read this. This is just a recap of the thing. So before we proceed to find the Z critical and finally the critical values, let's revise the steps that we have done up till now. Okay, because all the things are defined. Now we are just going to calculate the UCV and LCV values. First, you define the new quantity alpha, which is known as the significance level for the test. It refers to the proportion of the sample mean lying in the critical region. So for this test, alpha is taken as 0.05 or 5%. Once we have defined the alpha, on the basis of alpha, then what we do is we calculate the cumulative probability of UCV from the value of alpha, which is further used to find the critical value for UCV. Right? So based on this alpha value that we have selected, on the basis of what we do is we actually calculate the upper critical value and the Z critical value. Okay. So this is something that we will be doing. So you do not have to worry. I know that there could be certain, you might feel that this language is little complicated to understand. Do not worry. I'll first show you the calculation, and then if I'll come back to my if I'll come back to my this example, so this slide, you will be able to understand it. Okay, so I come to this. So okay, so now all of you please tell me to this question, just to see how many of you have this understand. What will be the area of the critical region on the right hand side of the distribution if the significance level for a two-tailed test is 3%? If the alpha I am taking as 3%, what will be the area of critical region on the right hand side? Yes, it is 0.015. Yeah, so 1.5%, and if you divide it by 100, it will become 0.015, right? So this is what you get over here. Okay, alpha is 0.03. Okay, please try this. Right. So Akshay, you have given a correct answer. Subhakaran, you have given a correct answer, right? So it will be 3. Why? Because it is one-sided test. It is not two-tailed test. It is just a upper tail test. In the upper tail test, everything comes on the one side. So in this case, alpha will be 0.03. Okay. Because if you try to see, this is the curve. In this case, I'm just doing one side tail test. That what is the chances that this value will lie in the critical region. And alpha I have taken 3% because now in this case, I do not have anything on this left hand side. All the 3% will be captured on one side itself. So that is why the alpha will be 3. Right, class? Anyone not clear on this or any doubts on it? Sure, Pooja. So I'll just explain it one more time. So if you see over here, see what is alpha, right? What alpha is the significance level, or you can say the error that the percentage of error that we are taking that my that null hypothesis will be false, right? What percent I am considering that if that value comes under that percentage, okay, so I will say that that my value, my null hypothesis is rejected. Okay, so let me just try to explain it again over here. Do you all remember we something if you remember, let's draw this. Remember when we started with that normal distribution, all these things practically also, just you all will have to collect the thing. We were defining something as -1 deviation plus 1 deviation, -2 deviation plus 2 deviation. Do you remember this? Right? Okay. What is the percentage that comes under before -1? If I am saying what are the chances that the value will be more than 1 deviation, what are the percentages of that? More than 1 deviation will be on this side, right? So up till here point, this is 68%. Total area on this side will be 68%. Right, Pooja, right? So complete area on this side will be 68%. Okay. When I say -2 deviations, in that -2 deviation, my confidence level increases, right? That my value is lying in that. What will be my chances that the value will be lying in that range? It comes out to be 95%, right? Right. So this is the 95%. Now, if I am in this range, 95%, this is my confidence interval. So what we are doing in this case is now we have to prove our alternate hypothesis. So what we do is we take the values up till 95% as our confidence interval, that if the value is lying up till this range, I am confident that my null hypothesis is true. Okay, this is what I'm assuming. But if the value is lying outside this range, I am saying my null hypothesis is false. Okay, now see, this is something that is statistically accepted values which we use. Making sense? So that means now this was 95%. So what is left? That is 5%. Okay, now in this example, what I've shown you over here is I shown you that, okay, in this case, I am assuming that all my 5% data point is lying on the left hand side. But if in case I am taking that error on the both sides, some part of the error over here, some part of the error on this side, since I know that overall data is 100%, so if I take 5% on this side, 5% on this side, so I will be left with only 90% of the acceptance area. That is why what we have to do is we have to break that 5 into two parts, 2.5 on this side, 2.5 in this side, so that my the rejection area is 5% only, and 95% area remains as my acceptance part. So this is so that is why we divided the data, the 5% into two parts. That was 2.5 on left and right. But in case my test is one-tailed, if my test is one-tailed, that is all my data I have to prove either on this side or on this side. In that case, I will assume that to be as complete 5% on the left hand side or right hand side. Okay, because I have to take that complete area onto my chart. So in this case, if you will see, it is saying what would be the area of critical region. What would be the area of the critical region on the right hand side of the distribution? Okay, if the significance level for an upper tail test, right? Upper tail test is in which we test onto right hand side. We do not test for that condition over here, correct? We do not test it on this side. So I have to take overall 3%. So if I cannot take on this side, so definitely my 3% will lie on this side only. Am I right, Pooja? So that is why I will say that my significance level in that case will be 0.03. Okay. Yeah, Rishabh, so is it clear to you what is this alpha that is doing? So I have just explained all the things in the detail. Shall I move ahead? Anyone still having any doubts on this area? Anyone? Swati, Sahil, Raghav, Raghu? Okay, so now we have okay, we'll just skip this. Now what we will be doing over here is we will be actually understanding that how we actually calculate that, these the numbers over here. Okay, now how we will calculate these stuff, let us try to understand it. Okay, now this is again, we will all have to refer to the z tables in order to find this number. Okay, in order to how we find the upper critical value and lower critical value. So for this we will just have to use the z tables again, the z tables that we had all used, like in the last class or yesterday also we used z tables, right? So same way we will be referring to that z values over here. Can anyone tell me what is 1.96 over here plus minus 1.96? Right, so so it is the z score. Do we know how we calculate this z scores? If you remember from yesterday's session, right? Yesterday's session, what we did was, if you just try to recollect things, see, the things will go connected to each other, right? So all the things will connected to each other. So if you will not be able to recollect the things, it will be a little challenging for you all in order to maintain the pace. So if you remember yesterday, in the yesterday session, what we were doing was, what we did over there was, if you remember from the normal distribution example, what we did over there was that we were calculating a z score, right? We were calculating a z score, that if suppose I have a particular value with me, I will say x minus x bar, right, Pooja? So that is divided by the standard deviation. That will give me the z score. Okay, that used to give me a z score. Now, once I got the z score, what was my next step? After calculating the z score, what used to be my next step? Say suppose I got the z score as 1.6, right, Rishabh? So what we used to do was, we used to refer a z table. We used to refer the z table and we used to see what percent of data is lying under the curve for a value of 1.6. Correct? This is what we used to do. So I am saying that my z is 1.6. So if you remember, we did a question yesterday where we got the output as 4.85%. Remember? Where we saw that we got an output out where the employee salary was, where the employee salary is, how much, if I pick up a random employee from 500, if I pick up a random employee from the sample of, those 500 employees, what are the chances that his salary will be less than 30,000? Remember that question that we did yesterday? Yes, class? Are you able to remember that question? Okay, so we got a number that, we are 4.85%. We can say with 4.85% surety that his salary will be less than 30,000. This was the answer that we got yesterday, right? Please, I mean, if anyone has any doubt, you can let me know. So I'm just repeating the thing that we did yesterday, right? So I'm just trying to ask it again and again. So please be a little active on the chat and try to respond so that I can get an understanding that you all are getting it. So right? Because I'm giving, as much as I can to make all of you understand and trying to explain as much as I can in the layman's. That is why I'm asking these things again and again. Okay. Now, yesterday what we did was that first we calculated the z-score and then we found the percentage, correct? Now, in today's scenario, what is happening? In current situation, what do I have? What do I have in the current situation? In current situation, I have the percentage. Okay, in the current situation, I have the percentage. I know that what is the area that I'm looking out for my critical region. That is 2.5%. This is the value that I know. This 4.85%, the value that we calculated yesterday, this percentage, in this case, I know the percentage, that this percentage is 2.5, correct? I know the percentage. Now I need to do the inverse thing. From this percentage, I want to find the critical value. Yesterday, I knew the critical value, I found the percentage. Today, I know the percentage, I want to find the critical value. Are you able to understand this circle? Right? So yesterday from here we got here. Today from here we are just doing the opposite. See, that is why I explained you this thing. So statistics is little confusing in that context, that sometimes you take sample from the population to prove population. Sometimes you again take a sample to define population, right? So this is the same thing that is happening over here. Nothing more than that. So now I know the percentage, I am finding the Z critical. Okay. With this percentage, we are able to get this number. Because of this percentage, we are able to get this Z critical. Okay. Now, how do we find it? What is my percentage? Because this is a two-tailed test. So 2.5%. Okay. So this is what lies under my rejection zone, 2.5%. Let us find this number. What I will do is, all of us, what we'll do is, we will open up something over here, that is Z table. Actually, I have that with me. Let me just see over here. If you want, I can put this on the drive also, in case you would like to.
Amit, I have a question here. So right now we are talking about two things. One is we have the standard deviation, and the other thing is the lower value and the upper value, right? So by standard deviation, what I understand is that it is the give and take on a certain value. Okay, I am considering this particular value to be the mean, and give or take, it can deviate by this much, a particular amount, right? So when we talk about null hypothesis and the alternative hypothesis, why aren't we taking the standard deviation as the limit itself? Is my question.
So with standard deviation, so if you say, when we studied that normal distribution curve, right? So with this standard deviation, what we do is we define our confidence interval, that how much confident can I be if I have the number between one deviation or two deviation.
Agreed.
Right? So that is where we use this. So ultimately, we are using the standard deviation only, right? So that Z score that you get, what is that? That is the number of standard deviations that you are considering within your permissible limit and outside that permissible limit. So Z score is the same thing, right? So that is what we are doing.
So in this case, the 5% is what we are calculating, as in what standard deviation that 5% area is, right?
But I'll just come to your point. Just give me one moment. Let me show you this chart once. Then I'll
Yeah, yeah.
just show you this. Right. So Z critical is this. See, if you see over here, so 97.5 is my acceptance area, right? Can you see? So, because basically I'll have to see the table. So there are two type of tables. One is left and right. So if you see over here, this table is telling me what do I accept, what do I have in the acceptance range. So if suppose rejection is 2.5, right? What will be the rejection? 97.5, correct? If 2.5 is my acceptance, so what will be my rejection? What will be my acceptance? 97.5. So if you just see in this table over here, let me just highlight that part. If you just see over here, 97.5, this is taking it from the right hand side, and we are calculating it from the left hand side. Sorry, from the right hand side, and this table is showing me from the left hand side. So this table is showing me the area from the left hand side. So whatever will be remaining, that will be the area that will be from the right hand side. So from the left hand side, I can see that 97.5% is covered. So that means 2.5 is left, which is I'm looking out for, and this value is lying at 1.96. Okay, so now I know that this is what my Z critical value is. So this is have I just I think I just replaced my no. Okay, so now if you see, we got that critical value at 1.96. So 2.5 was on this side, so that will be plus 196, and there was 2.5 that was on the left hand side, so this becomes minus 2.5 minus 1.96. So this becomes my Z critical value, right? So now if these are my critical values that I know, now using these critical values, what I need to do is I simply need to calculate my upper critical value and lower critical value. Upper critical value, the formula is mean population mean plus Z critical into standard deviation of the sample, right? So this you get over here upper limit, and this is the lower limit, that is 320. If your average comes out between these values, if your average of the sample, if the average of the sample comes between these two values, you will say we fail to reject null hypothesis. If the value comes lower than this or the value comes higher than this, you will say we reject null hypothesis. Okay, now this is the formula that we will use in order to find UCB and LCB. Okay, class. So now suppose I say that the sample mean, right? The average sales that happened of ACs were, say, suppose I say it was 360. So what will be my final result? Will I reject null hypothesis or will I fail to reject null hypothesis? If the average of my sample comes out to be 360, will I reject null hypothesis or will I fail to reject null hypothesis? Fail to reject, right? So that in that case, you will say you fail to reject null hypothesis. So this is basically how. So now this is the formula that you need to know. Based on the percentage, you find the critical, and you just have to put that critical value, that Z critical value in this formula over here. Once you put that value over here, you will be able to get your answer. Okay. So this is lower critical value, upper critical value. And if suppose the sample comes out to be 370, it is within the acceptance range. So that means you fail to reject null hypothesis. Yeah, here you have those questions, Raghavan. So you can try this question now. Let's just do this question.
Yeah, Amit, so that is where my doubt was that in the question it was said that the mean is 350 and the standard deviation is of 15, right?
So,
And the sample mean was
wait,
370.
wait. So what is 350? What was 350?
350 was the mean.
Mean of what?
It was in the question. I don't remember exactly the.
Anyone who can answer this? What was 350? Right. It was population mean. It was a population mean. So
Yeah.
we started with that example that, okay, based on an assumption that in the last few years, last couple of years, we have seen the average sales per store per month has been 350. That was the population mean. What was 15? This size, what was 15 that you were referring to?
15 was the standard deviation of the sample the mean. We have taken 36 stores into consideration.
And what was the standard deviation of the population? What was the standard deviation of the population?
90.
90. Right. So now we are clear on the terms. Now ask your question.
Yeah. So my question is that shouldn't the lower critical value and the upper critical value be plus minus 15 of 350?
Sorry, shouldn't the
LCV and the UCV be plus minus 15 of 350?
Why so?
Because that is the standard deviation, right? So if we look at the what I'm trying to say is,
standard deviation means that let's come back to that Sachin's example. Okay, let's come back to the Sachin's example. So I say Sachin has an average score of 55 and a standard deviation of 10. Okay, he has a standard deviation of 10. So what does that mean? So in most
the
of the
range
times,
is 45 to 65.
45. So this is not a range, right? So standard deviation does not define the range. So this is the wrong concept that you set it up into your mind, that it doesn't mean that ki Sachin ka score 45 से 65 के बीच में होगा. It is a general notion कि वो इसके बीच में उसके स्कोर रहेंगे. उसका एवरेज इतना रहा है. His score has been 55, but he has always been up and down 10 here and there most of the times. But yes, there have been instances where he has scored 200 also, and he has been out on 0 also. Right? That is what the standard deviation is telling me. Now, what we are doing on that, and on the top of that standard deviation, is I can multiply my standard deviation with 2, 3, and 4 as well. I can move as much far as I can from my mean. I can move as much far as I can. It's my choice how much far do I want to move from the mean value, right? So because now if I ask you that, okay, you know the standard deviation, you know the average of the Sachin. Now can you, with what probability, with what percentage can you tell me that he will score more than 70 runs in the next match? Now this is my question to you, right? I'm asking you, okay, Sahil, tell me what is the probability or what is the percentage, what is the confidence, with what confidence can you tell me that he will score more than 70?
That's a
First of all, tell
5%
me.
chance.
First of all, tell me. No, see, just you have just given a random answer over here. Now I am just splitting the questions for you. Is it possible that he will be able to make 70 score? Will he be able to make the score 70?
Yes.
Yes, right? Because I know
Yeah.
55 is the average. 55 is the average, and standard deviation is of plus minus 10. It has been up and down. But now
Yeah.
I am seeing that what will be the percentage? What with how much confidence can you tell me that his score will be more than 70? Okay.
That would be 5%, right? Because 95% chances that it will stay close to 55, which is the mean which we
No,
have considered to be.
no, no. See, what we are doing is, see, normal distribution curve has to be your base. And I'm not sure if you all are sitting with the pen and paper and trying to make these things at your end also. I'm pretty much not sure. So I will just advise all of you to make these things. If you watch the videos again, try to create these charts by yourself. See, because this is how I got this understanding. If you will look at the charts, you will never be able to understand the concept. So these statistics, if you all know, it requires some, getting hands-on. So if I make this chart, okay, Sahil and others, please,
Yeah.
if you also have your questions, you can let me know. What is this?
This is the mean.
Mean. Okay, this will be 55.
Yeah.
Score. Okay. Now, when you said plus minus 10, you are talking about the standard deviation, right?
Yes.
Plus 10 will be here.
Yeah.
Minus 10 will be here.
Yeah.
How much standard deviation have I moved? How many standard deviations have I moved?
One sigma.
This is one standard deviation. This is one standard deviation. What is the
Yeah.
total area that we have under the curve? What is the total area that we have under the
68%.
100? 100%.
Oh, sorry. Total area under the curve is 100%.
100%, right? So total area is 100%. What is the area that we cover under one standard deviation?
68%.
68%. Okay. How much area do we cover under two standard deviation?
95.
95, right? What will be two standard deviation? That will be plus minus 20.
Yeah.
Will it be plus minus 10 or will it be plus minus 20? It will be plus minus 20.
Plus minus 20. Plus
20, right? So in that case, you are taking a limit of 55 plus 20, that becomes 75. And on the other side, it becomes 35. Okay.
Yeah.
Now, just comprehend my question. In which case will you be more confident if I say, in the next match, he will score between 45 to 65? And in another case, I say he will score between 35 to 75. In which of these two options will you like to go with? You have to bet some money on it. That
Second
you will
option,
say
because it has more probability of success.
more probability of success, correct?
Yeah.
What is happening in that case is you are covering larger area. You are covering
Agreed.
larger area. So how much area have you covered in that case?
95%.
95%. Right. Now, if you increase that to 3 sigma, what will be that? So that will become plus minus 30, plus minus 30.
Yeah.
So that will be, that score will be, if I make 55, minus 30 will be 25, right? 25, that will be, I have 25 and 85.
Yeah.
This is what I will have the range.
Yes.
Right. Now, this range is something that covers 99% of his chances. 99%. Okay, now if I give you third option also, that okay, Sahil, Will you like to bet the money on, like, if you have a third scenario, he will score between 25 to 85. In that case, definitely you will go with the third option in that case, because your range has further increased.
Yeah.
So your confidence level has increased in that case, right?
Yes.
So your chances of error have reduced to 1%. If you are 99% confident that you will be right, so there is 1% chance that you will be wrong.
Yeah.
Right? And if in case you are 95% confident that you will be right, so there is a 5% chance that you will be wrong.
Yes.
Okay. Now this 5% will lie over here.
Yes.
Okay. Because now since we are breaking it into two parts, so 5%, because some part over here, some part over here, so it becomes 2.5 over here and 2.5 over here.
Yes, agreed. Yeah.
Right. So that is the percentage that I am considering, that if my output comes in this range, that is what that means my assumption was wrong. Okay, because I have accepted all the values, I have defined a range that I want to be 95% confident, so I have defined that range, and 5% I have defined as my error rate. If it goes beyond that, that means my assumption was wrong. Okay, so that
Agreed.
is the
Yeah.
same thing. Yeah, so that is the same thing that we have defined in that two-tailed test. That my null hypothesis is this. So I am defining a value of that. At what value will it be outside that range? Okay, if it comes in that error range, that means my null hypothesis was false. So we reject null hypothesis.
Okay. Okay. Understood.
Right. So like in this case, you said that Sachin will score between 25. He will score more than 25 and less than 85. That was my null hypothesis. But if he scored less than that, so that means it came into this region, which I had not considered. So I failed my null hypothesis. So that is what we are doing in this.
Understood. Yep. Understood. Thanks.
Okay. A little confusing. I mean, for the first time, definitely it takes some time, but please watch the video and try to do this question that I'm flashing on your screen. Definitely you will be able to get this answer of this. I mean, you will be able to understand it. Yep. So critical value method. So we have, you are saying, so the question was calculate the value of Z critical from the given value of this. And this is a two-tailed test. And for a two-tailed test at 3% significance level. So Pooja and Rishabh, have you all given the answer to me for this particular question? 2.17, are you giving me the answer for this question? Okay. So how have you found it? You can come, you can unmute and you can speak also. I mean, if you would like to. So it should not be percentage, Rishabh. So because critical value is not in the percentage. Percentage is already given to you, right? So Z critical is a normal value. It is not in the form of a percentage. Okay, so if you have found the Z score, you will call it 2.17, not 2.17%. Okay, so 100 minus 3, that gives you, yes, so 100 minus 3, that gives you 97. So now because it is a two-tailed test, right? It is a two-tailed test. So you will have to, for how much value will you calculate? For a two-tailed test. So you will have to divide that 3 into 1.5. You will have to divide that, right? That 3 into 1.5. So it will become 1.5 on the left and 1.5 on the right hand side. Okay. So if 1.5, I am taking it onto one side. So I am covering kind of 98.5 of the region. 98.5 of the region. .485. How come 0.485? I'm just a little confused again. I mean, so Pooja, how have you come to this 0.485?
Hi Amit. I mean, can I unmute and explain how I calculated?
Definitely.
Okay, so basically I divided chart into two parts. So 100 divided by 2, that will become 50. And the error also I did the same way. So 3 divided by 2 will be 1.5. So 50 minus 1.5. So, I mean, in percentage, that will become 0.485. From Z table, which is for two-tailed test, I referred the value of Z,
Okay, got
which
it.
was
Right.
2.1 and 0.07. So 2.17. That's how I arrived.
Correct. Yeah, so you're right. So yeah, if you have done it that way, yeah, definitely makes sense. What I would have done is maybe I would have gone it this way. I mean, both the approaches are correct. So I am saying it is 3% of the value. So 3% means that 1.5 on the left, 1.5 on the right, right? So like in the case of 2.5, what I did was, so if you remember in the 2.5 case, what I did was that this was the case. So we said 2.5 over here, 2.5 over here. So if I'm taking 2.5 on this side, so I'm left with 97.5%. So we found where that 0975 is coming. If in this case it is 3%, so it will be 1.5%. So 1.5 means I am talking about 98.5%. So this will become as, so this will become as 98.5. So I will look out for 0.985, right? I will look out for 0.985. So let us try to find that value. 0.985. Where was that? Over here. You have to just look out for that value, right? 98, so 92, 93, and 95, 96, 97. Here it is, right? 0.985, which is coming at 2.17. Perfect. So the Z critical will be 2.17 in this case. Okay. लाइट गई क्या? So class, any questions on this? So I think we have also done a lot of stuff. We extended the, when we can all take a quick short break over here, right? So that you can all just take a breather. So then we'll start after that. Okay. So all of you can just, let's connect in next 15 minutes so we can all take a break till Hello. Hi class, shall we start? Okay, so Sahil, Rishabh, others, please respond so that I can start. Okay, so class, so the things that we've done up till now, are they making sense? The what we have calculated? Anyone having any doubts? Perfect. So now what we will be doing is, let us move ahead with this. Okay, so now I'll come over here. So let me just present this over here. So this is something that you all did, right? So now this is something that you all were able to calculate, right? That this value of 2.17. Okay, now based on this thing only, you will have the next question that will be flashed on your screen. So yep, so here we are. Now this is the question that you have. So all of you please write down this question. All of you write down this question, because I will have to show you the formula for UCV and LCV. I'm sure many of you would have not noted that the formula. So I will show you that formula so that you will all calculate the UCV and LCV value. So this question is in the continuation only. So you have the G critical already calculated. You are given a mean, standard deviation, sample size. Okay, so you have to calculate the upper calculated by UCV and LCV. Anyone remembers the formula? It was mean plus minus Z critical into standard deviation. Okay, if you want, I can just write this over here also. Mean plus minus Z critical into standard deviation. Now calculate this UCV and LCV. Okay, so Pooja has given the answer, that is Subhakran. Okay, 44.68. Okay, I'll just wait for others to share their answers. Okay. So if I write it, this will be 36 plus, right, Z critical, that is 2.17 into, what shall I be multiplying this with? Very nice, very nice. All of you have given the wrong answer. All of you. All of you have given the wrong answers. Right? So my hypothesis was that you all will give the correct answer, and my alternate hypothesis was that you will not give the correct answer. So I reject my null hypothesis. Okay. Okay, so my null hypothesis was that you all will give correct answer, and my alternate hypothesis was you will not give the correct answer. So since you all have not given the correct answer, so what will I say? I reject null hypothesis. So this standard deviation 4 months, this is the standard deviation of the population. So how will you calculate the standard deviation of that sample? 4 divided by 7, right? 4 divided by under root n. So Naveen, so you have given the right answer over here. So 37.24 and 34.76. I don't know, your calculation is wrong somewhere.
Sir, it is upper limit it is 7.24 and lower 4.76.
Huh. Yeah, so Naveen, I'm not able to get it. So you are trying to ask me, or I mean, what? So Vishal is the only person who has given the correct answer, right? I was actually expecting all of you to be correct, right, in this case, because this is something that I was have been explaining you since the start. Any confusion on this? I mean, if you can, if you have, you can let me know if there is any confusion on the formula. So you all gave this answer, right? So this answer of yours was also available in the options. You all give this answer. But the correct answer is this. Okay. So now take this question. Okay. Right. So you will say fail to reject, right? Because your sample mean is 34.5 and the values are 34.76 and 37.24. It is lying between that. So you will fail to reject the null hypothesis. Okay. So you have learned how to perform the 3 steps of critical value method with the help of the AC problem, right? With the help of that AC problem as well as the above product life cycle comprehension problem. which was a two-tailed test, right? All the things that we have done up till now, they were all two-tailed test. Now, what would happen if you are working on a one-tailed test? So how will you do the things for your one-tailed test? Now you have a question over here. Now, you all will be expected to give the answers. So my null hypothesis is that the average sales are less than equal to 350. And my alternate hypothesis is that it is more than 350. Is this clear to all? Any doubt on this? Okay. Can you tell what kind of a test this would be? Is it a one-tailed test, two-tailed test? One-tailed test, okay. So now this is the question that you all have to do. So what will be the cumulative probability? 5%, right? So your acceptance region will lie in the 0.95. So in the previous case, when you were finding it for the 0.975, now you will find it for the 0.95 because everything is lying on the one side. Right? Okay. Now in this question, find the Z critical. What will be the Z critical value? All of you, please find the Z critical. One 1.96. How has Rishabh got the number 1.96? So Sahil, yes, you are very nearby to your answer. So Sahil has given nearby answer, right? Others? Yeah. So you take an average of that, right, Sahil? So if you have, if you don't find the exact value, right? If you do not see that exact 0.95 in your data, what you do is you take a value that is one value that is less than that and one value that is higher than that. And if that is the case, you just take an average of that. So that gives you 1.645. Yash, you have also got the concept. Okay. This is the table that I have. Okay, in this table, what I need to do is I need to find the 95%. So 90, just look out for that percentage. Where is that percentage coming? 95 is over here. This value is higher and this value is lower. 1.64, 1.65. So there are two values on which these percentages are coming, because I do not have exact 95%. I do not have exact 95%. One is higher and one is lower. So I will take these two values and I will take an average of this. So this will give me 1.645. Because I didn't have exact value, so I took one higher and one lower and took an average of that. Okay. Class, are we all sorted on this? Okay. Now, what I'll do is, let me just come to this PPT again. Okay, so you have the next question over here on your screen. You know, all these concepts that you're studying over here in the one session, right? So these are all things, actually, you know, they are the topics of the people who take statistics, right? So they cover all these things in 1 year, 2 years. So do not be, you know, demotivated that you are not able to understand 100% or you are still unsure. Definitely, you know, it will need practice. You will have to revisit the session. You will have to come back and you will have to see these things again and kind of ask the correct question, that what part is not clear. Okay. Only then, you know, you will be able to make sense of all these things. You also should know that what question to ask to make yourself clear that which part is not clear. The question should not always come like this, you know, we are not clear with the concept, because that means it was, since the starting, it has not been clear to you. So Sahil, you have given the answer. So what we have to do is, this is this. Now find the critical value for the given ZC and make the decision to accept or reject the null hypothesis. You have to give the correct answer also, right? That whether you accept or reject. I hope this time no one has made a mistake in calculating the standard deviation, right? This is 36 and 90. I hope you haven't made that correction, that error. You fail to reject. Okay. So, okay, you are saying that upper limit is coming 374. Okay. And the given value is 370.16. Yeah. So if that is the case, you will fail to reject. Correct. Correct. So perfect. So like Sahil, so you have got the correct answer. And Ashutosh, you have also got the correct answer. Yash, you are also correct. So all you are correct in this case. I mean, whomsoever has given the answer. Is it making sense now? How you are giving that conclusion finally? So now if some scenario is given to you guys, will you be able to give them the result statistically? That, you know, if you are sent to the Coke, you know, the Coke company, and they claim that, okay, you know, in every bottle we fill 300 ml of cold drink with a standard deviation of 2, right? So you are sent as a representative from the the fraud company to make sure that they are actually doing that, because if they are giving less cold drink, they are cheating the customer, they are charging more money. If they are giving more cold drink, in that case company is going into that losses, right? They are selling more cold drink and charging less money. Will you be able to do that analysis? You will take a sample of some bottles, say you take about sample of 100 bottles, you will calculate that and you will be able to give them the your conclusion on that. Do this. Now there is a small thing that I would like to explain you over here. Now this example is something to let you know about one more assumption that we take in the when we are doing the hypothesis testing. And that assumption is, I would like to tell you beforehand that sometimes what it happen is you are not aware what the standard deviation of the population is. Okay, like if you remember in this previous question, you know that what is the standard deviation of the population. But in case if I don't know what is the standard deviation of the population, and what they have done is they have given you the standard deviation of the sample. Okay, what in the question is, it is given you that the standard deviation of the sample is this. Okay, so how we will calculate the standard deviation of the the population is, what we do is we simply assume that if we are not given a standard deviation of the population, whatever is the standard deviation of the sample, the same is the standard deviation of the population also. Understanding my point? If in case the standard deviation of the population is not given to you, you will assume that whatever is the standard deviation of the population, the same number is the standard deviation of the population as well. Okay, am I clear on this sentence to all of you? Okay, so now again, so I am saying that, say suppose I had a sample of 36. Okay, what I'm saying is that I had a sample of 36. I had a sample of 36 and the standard deviation of the sample came out to be, say suppose 60. Okay, just a random example. I am saying this was the sample size and this was the standard deviation of the sample. What will be the standard deviation of the population? What will be the standard deviation of the population? 60. Okay, now if this is the standard deviation of the population, what will be the standard deviation of the sample? If this is the standard deviation of the population, what will be the standard deviation of the sample? 10. Right, so the standard deviation of the sample will be 10. So now this is again, this could just, now this is something like we assume this thing, this is how we go. You will say that first of all, Amit, you are saying this is the standard deviation of the population, then you are asking me to change that standard deviation. So this is like some assumptions that we have to make. So from that sample we calculated the population, the standard deviation, and then on that top of that we are calculating the standard deviation of the sample over here, right? This is something that is again a small assumption that you have to take. Okay, so now just do this question. So all of you create the correct null hypothesis and alternate hypothesis for the question. So yeah, so I mean, if Sahil, you are able to complete it, because I'm sure that you will be able to think of the following steps. You know the significance value, you will find the Z critical, you will find the UCV, and you will claim whether your null hypothesis is true or not, right? These are all the steps. I think these should be now clear, crystal clear to all your minds. We have done a lot of examples over here, right? Archery game, we have done that. The AC sales, we have now done this, the Maggie example, the Sachin example. So we have done a lot of examples over here. In fact, you should not be waiting up for the next questions over here, because they will be the same repetitive examples that we will be having. Question. So what is the null hypothesis? Null hypothesis is, anyone who can share it over here on the chat? Okay, so you're given the fail to reject. Okay, so you're given the complete answer as well. Perfect. So let's see if everything goes as what you have mentioned. I'm little doubtful on that UCV that you have calculated, right? Because if it is 3.5 and upper cannot come around you 3.4. Can you just check it once that everything that you have done is correct? I mean, it can be correct also, so I'm not sure. Z critical should not be 1.6, because we are taking 3% significance, right? So 3% significance, if you will take, this is something that you calculated for 5%, right? 95% area. So it should not be same for it should not be the same for 97 also. So Pooja, this 0.845, you are telling me the critical value, the Z critical value. Okay. I mean, see, if I check it out, 98.97%. No, I don't think you are right. 97 is something that comes approximately over here, right? 1.88. 1.88. So I think someone gave that answer 1.88 over here. Right, Pooja? I mean, so both the two Poojas over here. So one Pooja is correct and another is wrong. So Pooja Jawali, so your answer is correct, right? That is 1.88. Okay, so if I know the critical value, now everything is sorted. What was the mean? If I go back to that question, so this is what you have. The sample mean is this. Find out the critical values to make a decision whether you should raise alarm or you should raise an alarm against that company or not. Now this is something that you have to find out. Pooja, okay, so Pooja, your question is, do we assume sample mean? So population mean will be 2.5, right? The average should be 2.5 only, right? Because the content cannot be more than 2.5, right? So we assume that, okay, that we will take the average as 2.5. You will be taking the average, the population mean as 2.5 in that case. So 2.5. So Sahil, still your answer is not correct. Right. So Akshay, your answer is correct. So your UCV that you have calculated, that is correct. So upper limit will come as 2.61. Yes, yes. Pooja, your is also correct. Upper limit will be 2.61. And the mean that we calculated was, that was 2.6. So will I reject hypothesis or I will fail to reject hypothesis, null hypothesis? Fail to reject. Perfect, perfect. Right, Akshay. So that is what we will be doing over here. So we will fail to reject the null hypothesis. So here is your answer.
Why are we dividing 0.6 by 10?
This is something I explained you now.
No, I know the concept, and I'm talking about this particular case. Over here we uh, the standard we are assuming the sample deviation is 0.6, right?
Right.
So we are assuming that it's the population deviation is also the same as 0.6.
Right. So if population deviation is 0.6, what will be the sample deviation?
Oh, okay, okay.
Yep.
Okay, I thought if you're already assuming both to be the same, then we don't have to
No,
divide
no.
it.
So both can never be same, right? See, population deviation and sample deviation, they both can never be same. Okay.
Understood,
So
understood,
whatever the
understood.
population is, the sample will always be population divided by square root of sample size.
Sample size, understood. Okay.
Shall I move ahead? I'm not sure, like, you know, like, I hope all of you are trying it at your end. So Akshay Rao, I mean, is it the same, right? Akshay Rao PCIC, one is Akshay C Rao C Corp. I'm not sure if you, Ranati, Shruti, Bhavani, Amit, Prince, Sanjana, Sushma. I'm not seeing any response from you guys. Uma.
Sure, I'm trying to calculate, but it takes time actually. Or I'm not. I grab it, but I cannot be able to do it fast. Actually, that's why
Okay.
I'm not able to.
Okay. Do this. Answer this question now. So this is more like a theoretical question, but you will not be able to give the answer without solving it. If you increase the sample size, so the question is, if you increase the sample size, how would the z-score and the critical value would change? So Sahil, you say Z's critical remains the same. Akshay, you also say the Z critical remain the same. Anyone else who thinks that Z critical remains the same? Correct, right? So Z critical will not change, right? Why? Because Z critical is something that is dependent upon this 3%. Now this is not changing, so my critical will also not change. Making sense? Because Z critical, how do you find it? आप Z critical कैसे निकालते हो? आप Z critical निकालते हो इस परसेंटेज को देख के. आप इस परसेंटेज को देखते हो टेबल में, उसके अगेंस्ट जो भी नंबर आ रहा होता है, that becomes your Z critical. अभी नंबर चेंज नहीं हुआ तो जी क्रिटिकल भी चेंज नहीं हुआ, क्योंकि हम सिर्फ सैंपल बढ़ा रहे हैं. इफ आई एम इंक्रीजिंग द सैंपल साइज, अगर मेरा सैंपल साइज इंक्रीज होगा तो मेरा व्हाई विल माय यूसीवी रिड्यूस? व्हाई डू यू से दैट माय यूसीवी विल रिड्यूस? Correct. Right, because standard deviation will decrease, right, Bhuvneshwari? So of course your standard deviation will decrease. Now because the standard deviation will decrease, so you will be multiplying your z critical with a smaller number. If you will multiply with a smaller number, your UCV will come small. So that is why your this will change. That is why your your critical value will change. If the sample size increases, the UCV decreases. If the sample size decreases, the UCV increases. Right? So you have the final solution over here. Cumulative 1.88. Your critical value came out to be 2.61. Sample was 2.6. So the decision is you fail to reject null hypothesis. And with this, we come to a closure point on the side of hypothesis testing. Was it interesting? Others? I hope all of you are active, right? I mean, I will say, Sahil, it's not a lot of practice that is required. It is more about understanding, right? Because to be very honest, you will never be calculating these things anywhere. No one will ask you, or in your project, you will have to calculate this thing. And what we do is basically, if you will understand what exactly is happening, when you will see these results in your model, you will be able to understand that significance levels, because we will be relating these things ultimately to the significance of the variable. Okay, like for example, if I'm saying if I have to predict car price, so car price will depend upon say suppose it will depend, I'm saying that it depends, I'm saying it does not depend, the car price does not depend upon the engine size. Now that is my hypothesis. I am saying my car price does not depend upon the engine size. You will say that yes, it depends, right? That will become the alternate hypothesis. Okay, now you will have to find its you will have to find its the significance level. If the percentage comes out to be less than 5%, right? If the percentage comes out to be less than 5%, you will say that yes, we reject null hypothesis, right? This is what we are doing. If you actually see, because this is something that you will again be using this again. So now if you if you just see, it is just in a little again a tweaked way. If I'm asking you a question, so like Rishabh, you have now you wanted to have more questions, so let me ask you a question over here. I'm asking you a question that car price, okay, I am saying car price depends upon weight on the engine size. Okay, I won't be able to write much. I am saying car price depend upon engine size. So I mean I am saying it does not depends upon the engine size. Okay, my null hypothesis is it does not depend on it. Okay, what will be my alternate hypothesis? It depends on it. Now, how will you conclude that which is true? I am saying it does not depend. You are saying it does depend. So how will you conclude that thing? Right. So you have to conduct a test to prove it. Now, if I say, you know, there are a lot of tests in this. One is T test, one is F test, one is chi-square test, right? So there are a lot of tests for this to solve this. And all the tests you will have to learn, right? Basically, everywhere for every kind of a solution, there will be different kind of a test that you will be doing. Over here, almost every places, what we have done is we did the Z test, right? Because we were looking for the Z values. Similarly, you have T values, you have F values, you have chi-square values, a lot of things. So are you all ready to learn all these things? Z test, T test, P test, F test, chi-square test, right? So these are all the things, you know, that will actually help you out, all these answers and everything that we will be doing, right? So definitely we will not be going into a lot of depth for all these different tests. Okay, T test, F test, chi-square test. Definitely we will not be going into a lot of depth over here, because if you see, you know, like at almost 2 sessions it took us to understand just one test over here. If we will do all these tests, so we will have to spend at least 2 months just to understand the tests only, right? So which is definitely in depth, I'm saying, right? Doing a lot of examples and understanding everything. So that is definitely, it will go out of the scope to do this thing, but all the things technically depend upon this hypothesis only. So that is why I have spent an ample time over here. Okay. So with this, you know, I mean, definitely you can all just try and go through the videos. I've already uploaded this PPT also on the drive, so you can you know, use this PPT also if you need for any of your reference purpose. So you can go through this. Okay, and yeah, so I think, so what is the time? It's almost like 11:30, so I don't think it makes a lot of sense to start with a new topic today, right? Because we have already done a lot of stuff today, which was really, you know, it would have been exhaustive for you. Okay, so, you know, like in the next session, what we will be doing is we will be starting with, I will just like to give you a heads up for that. We will be starting with the part that is EDA. Okay, so like if you see, like, you know, yesterday's session also, today's session also, we haven't used R anywhere, right? We haven't touched the R somewhere over here. At any point in time, we haven't touched R in this case. Now, because this was all about understanding the concepts into this. Now what we will be doing is we will be actually starting with the process of EDA, that is exploratory data analysis. And on that, that is something that where you will need understanding plus the R as well. So you will be doing all the things onto that. So we will be doing the R, we will be starting. So EDA is about, you know, we will have some data sets with us, exploratory data analysis, where what we do is we explore the data. What kind of a data do we have? Is the data neat and clean? Can this be used for further analysis? And are there any variables which need to be deleted? You create a lot of charts on that in order to understand what each variable is telling you, how that data is. You remove the outliers from the data. You, in case you have to create new variables, all those things, they come under the part of EDA, exploratory data analysis. Okay, so this is something that we will be starting up with the next session ahead. Okay, so with that, anything you would like to ask? Any question before that, before we close with this session today? Yeah, sure, Uma, I'll put up the Z table also over there. Okay, I will put up the Z table as well onto that drive. Let me just do it right away, you know, otherwise, you know, what happened is I actually forget that. Just give me a moment. I'll just do it right away. Yeah, Rishabh, I'll be telling you the ANOVA as well. So do not worry, we will be doing all the things. ANOVA is not that typical. ANOVA is something which stands for analysis of variance. Okay, that is what the full form is. Analysis of variance is, like, for example, you know, if I just try to explain you this thing in a very layman's language. It stands for that, if suppose I have two machines with me, and both in my factory, I have two machines which I use to fill cold drink into my bottles. Now I want to be sure that both the two machines are operating properly. It should not happen that one machine is filling 300 ml and another is filling 310 ml. If there will be any variance in the two machines, that can be a problematic for me. Okay, so how do we understand the variation between the different machines? So that is called as ANOVA, analysis of variance. So it is all about mathematical formula. So there is just one mathematical formula that we have. So I'll be telling you that. I'm just uploading. Where did I upload that? Yeah, so there is this section of R material. Over there, you will find a PDF file that is hypothesis testing. Okay, and over here in that R material, only what I am doing is I am just trying to I'm just uploading this Z table as well, which you can refer. Done. So I've uploaded all the things. I mean the PDF also and the file also. Okay, class. Yeah, Risha, we will be covering that. Okay, so any doubt till that time? So I uploaded one more dplyr exercise. If you would like to do that, you can try that also. And yes, so that is what I had from my side.
Amit, so the book that you had uploaded, in that?
No. It is just the same PPT that I was showing you. It is just the PDF format of that.
So if in case we want to solve more questions, where can we refer?
See, one thing is you can also try it by yourself, right? It is just about you can create the questions, by your own understanding also if you want to do it. Just create some questions like this, say suppose, my friend, she says that she will score on an average of 80 marks in the exam. So, right. And with the 3% of confidence interval, you want to take whether she will be able to do it or not. So you can try that out by yourself. So first of all, I will say, right, first of all, my a suggestion to all of you would be to do all these same questions one more time, right? Otherwise, definitely, I'm 100% sure if you will not try the same questions again, by next week, you all will be, washed out with the concept. So just try this same questions once. And I'm 100% sure if you will just try these questions also one more time by your hand, without referring to the video, by just going through that PPT slides, if you're able to do it, you will not need any more questions for your practice. Because if you would have seen, it has multiple questions which judge you from your from both the sides, for two-tailed test also, one-tailed test also, and creating hypothesis also, and giving your results, conclusions also. It has questions related to each and everything. Z critical also, where how you calculate the Z critical. But still, I will try to see if I can create some questions for you. I will definitely try to put them on. I think I have one assignment with me on the hypothesis testing. Let me just give me 1 minute. I'll try to upload that. Hello. Yes, Amit.
So can you please tell me about the Z-score 1.88, because I'm able to grab everything, but this cheese thing I'm not able to grab. Z-score 1.88 right now. The last question which we had done about that, I able to grab the like significant level or all the things, but Z-score 1.88, how it's come actually. That's the point. I open my Z-score table and I'm able.
Okay, I have an assignment with you. Just give me 1 minute, right? I have an assignment with you. What I'll do is I'll upload this assignment for you on this drive. On the hypothesis testing, I have assignment with me. I'll do that. Okay. Yeah. So, okay, Harmeet, can you share your screen so that I can explain you what your question is?
I'm on the phone actually. I cannot be with that.
Okay. So do you want me to share my screen? You want me to share my screen?
Yeah.
Okay, I'll just do it. So like, in the last class, we studied how we justify our hypothesis on the basis of critical value method. There is one more method that we have, that is p-value method. This is something that I'll also be discussing again in next session, in the next class. P-value method is also something that we have. This is also very simple, the same way. It is just the opposite of that. So you were asking me about that 1.88, correct?
Right, correct.
So calculate the Z critical for this test at 3% significance level. This is the question?
Yeah.
Okay. So I will just ask you a couple of questions over here. So which test are we doing over here? Are we doing a two-tail test or a one-tail test?
One-tail test. This is a one-tail test, and here it's a upper tail test, I think.
It was upper tail. Yes, it was perfect, right? So it was an upper tail test. So this was it. So I am saying if the value comes out to be more than critical value, I will say that my alternate, I reject null hypothesis. That means the products have higher lead content in that, right?
Yes, right.
So what is the significance that we are taking? We are taking a significance of 3%.
3%.
Right? Now, because this is a one-tail test, so all the area will lie on one side only.
Right side.
So the 3% will come on this right side.
Right, yes.
Okay, so 3% is my rejection area. So how much area I am left with the
97,
acceptance?
97,
right? 97.
Right.
So 97% is nothing, 0.97.
Yeah.
Now you have to check in the Z table where that 0.97 is coming.
That's the problem actually. That's the main problem actually. I cannot be able to.
So this is the table. This is the Z table. I have uploaded on the drive also. Okay, this is the Z table that you have. This is a standard. So this is nothing that mine is different and your will be different. It is a standard table that is used by everyone. So now what I'll do is I need to find this value 0.975. That's it. That is what I have to do over here.
Yeah. Yes.
So if you see, as you go on the right hand side, the percentage is increasing. 50%, 76%, 87%, 90%. So as I'll come over here and I will find 97% to be coming somewhere over here. You can see it over here, 9699. That is approximately 97 only. 0.97.
Right.
0.97. Okay. So now just see this value over here. So this number is coming at
1.8.
1.8, right? And then the second decimal is something that you have to see it from this top over here. So this number is 0.8. So 1.8 over here, this is the 10th decimal. So 1.8 you have got from the left hand side, and the next decimal number you will get from the top, that becomes 8. If had it been over here, this number would have been 8, the number would have been 1.87.
88. Right. Thank
Now
you. Yeah, it's clear. Yeah, it's clear. It's clear. Thank you.
Okay. Okay, so I think any questions? So Subhagran, okay, you have shared a code over here. So you are saying you are getting some error in this. Okay, let us see at it. So you created this. So I'm just copying your code. Okay, Subhagran. So I'm just in the R Studio. So A is our unit. Got it. CL16, you are saying sample of A. Okay, that is correct. Then for A over here, CL16, it's working. And I got it. So I have 1000 numbers in this. I have just copied and pasted your code only, Subhakar. Are you there? I mean, I think, you know, you are asking to this, right? I think, so I will just watch on my screen. You have just shared this copied code from here from me, right? This is what you have shared with me, correct? I think your problem is over here, right? So you have shared this thing. So this is in the console window, this code has been executed. So if you want to see this variable is over here, CL16. This variable is created CL16. If you will see in the environment, you will see that variable over there. This is the CL16. And you can see it is written 1:1001. That is, there are 1001 numbers in it. If you want to see it, you just write CL16 over here. You will be able to see all the numbers. But what we did was we created a histogram on it. So I said I want to create a histogram on this CL16. So I created a histogram on this. So I got this chart. Okay. Okay, Jyoti, so your error in plot. So see, this is something that I told you yesterday. You know, this error comes up if your area is less. Okay, if the area is less and you try to create a chart, see, I've got this figure margins too large, correct? So I will start getting that error in that case. You see, figure margins too large. I'll increase the area. I'll rerun it. It creates it. Okay. Any other question I missed? You know, because sometimes what happens is there are a lot of chats that come up, and I end up missing the questions.
I mean, like statistical service companies, like companies who do using surveys, are basically depend on this. Actually, like a weather forecasting company, okay, like a movie reviewing company. Sorry, here India has 4 metropolitan cities are there. Okay, Delhi, Mumbai, Lucknow, or something. So we have to grab data from all these 4 cities or states. Okay, so मैंने दिल्ली से 250 बंदे लिए और लखनऊ से 500 लिए वगैरह वगैरह करके सैंपल्स कभी हमेशा एक से होते हैं, अलग अलग भी हो सकते हैं, हमेशा एक से नहीं हो पाता.
See, that totally depends upon your survey that you are doing. ठीक है? So like for example, आपका सर्वे है, if your survey is लोगों को किस टाइप की मूवियां पसंद है, okay, what kind of movie do people like. अब मेरा सर्वे स्टेटमेंट बहुत सिंपल है, तो व्हाट आई कैन डू इन दिस केसेस, मैं कुछ लोग राजस्थान से उठा लिए, कुछ हैदराबाद से उठा लिए, कुछ मैंने कहीं से उठा लिए, कुछ कहीं से उठा लिए. उन सबकी प्रेफरेंस मैंने पूछी कि डू यू लाइक हॉरर मूवीज, रोमांटिक मूवीज, कॉमिक मूवीज, और ओके, तो वो लोग मुझे एक रिजल्ट देंगे कि हमारा हमें ये मूवी पसंद है, एंड बेस्ड ऑन दैट आई विल कम टू अ कंक्लूजन दैट यू नो पीपल लाइक दिस काइंड ऑफ मूवीज. बट इफ सपोज माय बिजनेस स्टेटमेंट वाज what kind of movies are admired by different people across the states, right? So in that case, my result will change. I will be looking into it, like for example, okay, I will pick up a data of people of Punjab. I will say, okay, what kind of movies do you like, and I will give a result on the base, so that Punjab people like this movies, Delhi people like this movies, Hyderabad people like this movies. Okay, so that totally depends upon the business statement. So let me all give you a question, right? You all just come up and think on this thing next week. I would like to see that how many of you are able to come up with some insights on that. How many of you over here use Milk Basket? Milk Basket, do we have anyone who uses Milk Basket? You know, it is something like a big basket, right? So like you have a big basket, it's a online shopping store, okay? And similarly, there is another company that is Milk Basket as well. I'm not sure if many of you have heard of it. Okay, so let us assume that Big Basket, have you all heard of Big Basket? Miss class, yes, no, yes, no. Okay.
Yes, sir.
Okay. So now Big Basket, you know, when they started their services in India, okay, what they did was that they used to give free delivery. Okay. They used to give free delivery on the items. Now, couple of months back, they introduced that they will charge 100 rupees monthly. They will charge 100 rupees monthly. Okay, I'm just giving this hypothetical situation to you, and I mean the situation is real, and I'm not expecting some statistical answers. I'm just expecting some hypothetical answers over here. Your understanding based on the situation. Couple of days, some days, I will say a couple of months back, they increased the. They said that we will charge 100 rupees per month for your deliveries, and now just few days back they said, okay, we will now be charging 200 rupees per month for all your deliveries. Question clear? That they said, okay, like initially they used to give free deliveries, but couple of months they said we will be charging 100 rupees per month for all your deliveries. Now they said that we will be charging 200 rupees for all your deliveries per month. They have increased, doubled their charges. Now, question that you all have to think of is, why would they have done so? What circumstances would have led them to put on the delivery charges? And if yes, if they have, if they are applying the charges, what do you think it will impact the customers? How it will impact their customer base? Will their customers reduce or will their customer increase? You have to come up with the hypothesis on this. Okay, it is your call. What do you think? You want to Google out something, you can do that. You want to do anything to do that. I just want to see how much you are able to collect that information. You have to give me a base that, okay, if Big Basket has increased their charges, what could be a probable reason for that? Why would they have come up with that, the situation that let's increase or double the amount, right? And definitely they would have also thought this thing, right? It's a big company that, if I will double the charges, I might lose some customers. So what things they would have thought of for doing this stuff? Am I clear on the question? Yes, class? Are we all clear on the question? Okay, so you have a week's time.
Yes,
Think on it. Yeah. So think
I
on
mean,
your answers.
just a minute. When they charge 100 rupees, when they charge 100 rupees, is there any special delivery or anything
No.
they?
All the deliveries. So
all the deliveries.
So all the deliveries, they were free. They said, okay, we will be charging 100 rupees per month now going onwards. It will be charged you in the starting of the month. Now in that month, whether you order 100 times from us, you order one time from us, we will be charging you 100 rupees. Okay. Okay, the class. So see you all next week. So till then, enjoy, stay safe. Okay, thanks Yash. Thanks Akshay. Thank you, Sahil. See you all next week. Thank you, Swati.